Hello, my name is Michael. I am an ICT and software student specializing in artificial intelligence. Okay, so the problem that this project is basically meant to solve is all of us have electronic devices. We have phones, we have monitors, we have so many other technological devices. So basically when these devices go into a warehouse or a recycling plant, sometimes based on the environment of the recycling plant, sometimes these devices can end up blowing up. Now, when these devices blow up, a lot of things can get damaged in the warehouse, not just in the warehouse, but also in the environment itself. So we are tasked to basically kind of find a way to solve this problem. So you might ask, like, why exactly did we use an AI in this project? So imagine as a person, you have about, let's say, 100 a day devices to work on. There's a chance that you're going to make a bigger error just because you're tired or just because you're hungry, one of those kinds of situations. So the reason why we bring an AI into this is because we want to kind of reduce that error aspect. Because an AI can never get tired, an AI can never get hungry. So we used CNN, basically the core of it was CNN models. Now these CNN models were from VGG16 down to MobileNet to other popular CNN models. The CNN models case, the main purpose of the CNN models was look at the device and then in some sort of way, can the CNN models figure out from the dimensions of the device, maybe from the look of the device, if there's a battery inside of it or not. I would say the biggest challenge for me in this project was basically just figuring out which model is the best kind, because we had to go through multiple iterations of just running the models over and over and over, trying out different models, tweaking the model all the time. That was the main challenge of it. The way we measured our CNN model this time around, instead of just using basic accuracy, because as AI students, there's something that we have to realize. Accuracy doesn't mean the AI is good. Because you can have an AI that's like 90% accurate and then all of a sudden it fails at some aspect. So the way we looked at the AI, the way we measured the accuracy of this AI is basically by using something called a confusion matrix. Not to bore you about it, but it basically looks at how many wrong predictions it makes versus how many proper prediction it makes. And then we can scale it that like the AI makes way more proper predictions than wrong predictions. So the end result that we finally got was we have an AI now. It's like we embedded it into our laptops and then it's connected to a camera. Now this camera can basically just have an overview of the phone, basically looking at the phone from a top view, and then it can see, basically it can predict is there a battery or not inside this phone, which is absolutely insane because when we looked at it, we were a bit surprised that it could do it. So yeah, that's the final result of just the AI can just look at the phone and then predict if there's a battery or not inside. The biggest learning as a future professional is that I kind of learned that a lot of the times you just have to experiment quite a lot when it comes to AI. Like AI is not just, you have to be very creative. You have to be very creative and you have to be willing to experiment a lot, because AI is not just, you can't just say, oh, the AI is giving me a 90% accuracy, or this AI, it predicts this thing very well. You have to try different things. You have to always continuously try different things. And that's something that I was able to grasp during this project.